So good morning, everybody. And it's, yeah, I think Eileen explained the situation. So it's with pain in my heart, I cannot travel to Istanbul. I was looking forward, in fact, after, yeah, a crazy almost 2 years that we are all in, to finally meet in person. But okay, the situation has decided otherwise, because I was at CPHI Milan last week. And on the way back, I was in contact with somebody who was positive. So I had no choice and get tested. So everything's fine. But unfortunately, I cannot be there live. So really sorry for that. But I'm happy, let's say, we can use still modern technology. So we can obviously stick to the schedule. And I'm happy, really happy to talk to you about dry granulation today. So I'm not sure. I mean, there's obviously, I think, probably some people who are familiar with that and some people who might not. So I'll start with explaining, okay, what is basically dry granulation and what are we going to do? So in pharmaceutical and actually, so within our company, IDEX, Fitzpatrick, and Fitzpatrick being sister companies, as well as Metcon, microfluidics. So we all focus for dry granulation only on the pharmaceutical industry. And basically what we're going to do is the most, let's say, common place in pharma where roll compaction is, let's say, used is in front of the tableting machine. So it's kind of an intermediate step in most cases. So you start with, or you obviously have a lot of, let's say, low bulk density powders, which you want to tablet. And if you feed those kind of materials non-flowing, you feed them into a tableting machine, you can potentially have all sorts of issues. Meaning capping of the tablets because of air that's entrapped, low capacity, a lot of rejects, difficulties with feeding, sticking to the plungers, and those kind of, let's say, all of those kind of problems are resolved if you roll compact the material before you tablet it. And on the tableting itself, it's our good, let's say, friends from Metal Form, I think, who are experts in this, who will tell you later more about the tableting, the compression, the compaction simulation as well. But if you can see the picture well, so this is the typical steps that we have in a compactor. So I'll talk a little bit about the process more in detail. So what you're going to do is basically we're going to compress and make a compacted sheet. And after that, we will granulate it into a more granulated material. So which is better flowing, which is densified. It's much easier to feed on the tablet press. And you avoid problems with sticking and so on. Sticking, I'll explain that later too, but sticking in a roll compactor is not a problem. I mean, it's a continuous process. That's fine. And I'll just, if you give me 1 second, I'll change the pointer. I hope you can see this better. So going on, so the advantages of dry granulation, if you compare it to other granulation methods, and what's very popular in pharma is wet granulation. If you compare that, dry granulation has a lot of advantages. Mostly it's to do with, okay, the cost, and that's investment cost. In wet granulation, you have a lot more steps. You need to add moisture, which you're going to dry later. So there's less process steps. It's a more easy to control and validate process because you're not adding moisture. It's a dry way of granulation. And also obviously the running cost. So there's less equipment to clean. There's less energy consumption, which is also, let's say, very big these days. So it's it's really, and it's a continuous process, whereas these days, still today, a lot of wet granulation processes are still batch processing. So it's also very repeatable. So once we've set a good set of parameters for a particular product, you would work with recipes. The operators can basically automatically restart at any time later. And if you, let's say, with the same material, the result will be exactly the same and obviously very stable. The next thing to see is if your product is suitable for roll compaction. So you basically, obviously, you need to have a compressible material. So a lot of the products in pharma are, and especially products that you would tablet today are very suitable, obviously, for roll compaction. We do some initial testing, and I'll show that in this graph, where we basically would compress tablets at different kind of pressures. And we make this curve. So other things that we see during this test, and I'll explain that in a second a little bit more. So we can see, okay, is the product releasing easily from the, let's say, from the plunger and the die? Is there sticking? It will help us to determine, okay, what kind of rolls do we need to use? What's the hardness is what we're going to measure. Compaction ratio, and we make an estimation of the process pressure. And process pressure and the pressure that's used or needs to be used to have a good result, that's actually key for roll compaction. So if you look at and this is just a small initial test that we can do for you, let's say on let's say 1 kilogram, even less in fact. And what we do is we would compress at different, let's say, at different pressures. And what you tend to get is that you will go from your loose bulk density, you will see that goes up pretty quickly. And at some point, let's say the curve will flatten. So it means that if you apply more and more and more pressure, there's no gain anymore. And in fact, there's a number of reasons why you should not be doing that, because you're introducing energy and too high pressures where it's not required. One of the more important things is also, and again, I think our colleagues from Metal Form will go more into detail, but the recompressibility is very important. And so we are an intermediate step. We compress the material, we granulate it, and the granules need to have a good recompressibility to form a really good tablet later on. This was an initial manual test we did for many years as a service to our customers. Nowadays, and this is brand new, I'll show that also, we have a so-called LCS, the lab compaction system, and that was the one machine that was not missing, but it's because we had obviously a representative machine before to do R&D, pilot work, initial test work, but it was quite a large and heavy machine, and now we brought out a desktop lab compaction system, which is really exciting actually, and there's a lot of extremely good responses on that, but I'll show that also in a second. So there's different options now to do initial test work. So looking at the process, so basically there is two rolls, there's and then there is a feeding system. So maybe let's talk first about the heart of the machine. So the two rolls, they're counter rotating. One roll will be fixed and one roll will also float horizontally, let's say, towards the product or away from the product, making a certain roll gap. So this roll is flexible or floating. The hydraulic pressure that you set or the roll force that you set behind the roll will make that you have a very, very constant pressure on the material that goes through. One of the crucial things is that the pressure that comes, the ribbon that comes out is very obviously consistent, and the pressure is the most important for that, because that determines the hardness and is directly related to your product quality that comes from the compactor. So that's one thing. And on the CCS, at the moment we have on the market one of the most precise, let's say, pressure systems to control this very, very accurately. Obviously, you're talking about, okay, for higher capacities, heavy equipment, but still we're measuring obviously within 0.1 millimeter the roll gap, and we have a very, very, even when these rolls move, we always have an extremely accurate pressure on the material that comes through. Second thing that's really important is a double feed screw. So the feed screw system, why is a double screw system so much better than a single screw system? It's simply because you can separate the parameters. So you have a horizontal screw just for feeding, and you have a vertical screw which has two purposes. So one is to pre-compress the material just before the rolls, right here. And then the second is to remove the air from the material. If you're not capable in the machine to remove accurately the air from the material, you will get poor results. Poor results meaning that air will be entrapped in the ribbon. It will break up. It will make that the ribbon can be softer. It can make that there is more fines, and so on and so on. So if you, even with very low bulk densities, you remove the air really good. And by design, the best way is actually the vertical feed screw. We are also the only ones that use a higher speed vertical screw. And that's again beneficial. Also the vertical setup, all of that is beneficial to remove the air in a more efficient way and compress just before the roll. Before the rolls, sorry. So how to optimize, and I know on the left, it's just a screen from the controls and you probably cannot read it, that's okay. So I just want to explain, this is, here you see, for example, the whole compactor. So you have the horizontal screw, vertical screw, the two rolls, an accurate sealing system, and then there is a mill or a granulator underneath, obviously to granulate into a certain particle size. So how do you control and how do you optimize the system? So the very first thing to do, if you have, assume you have a new material, you would probably test it on a lab system first or on small scale, which is fine. So you have an idea about the pressure. So you have some kind of a starting point. And basically what you do is you set it at the pressure that you found from that test. If you don't, you can also do it on the machine. You just start with a low pressure because the last thing you want to do is to over compress. So you install low pressure, a medium speed on the vertical screw, and let's say a low speed on the horizontal screw. So because the pressure is low, it will be easy to form a roll gap. So once you start feeding, the rolls will spread and you will see, okay, I have a roll gap of maybe 1.52 millimeter. Then later you will increase both the pressure and the feeding until you work up to a point where you are basically seeing, okay, I have a really nice compacted sheet that's coming out. And that is, let's say, nicely compressed, and then you granulate it afterwards. This is the practical approach. And there are obviously more scientific approaches. We can obviously, from small scale, we can help you to convert those kind of parameters. And again, I refer also to, let's say, maybe to Metal Farm, who is basically doing this kind of simulations as well, which they will explain later in this seminar. So, so that's a little bit in a nutshell. The next thing that's maybe important if it comes to capacity, that's maybe more important for people who are using already the compactor. So the machines, all of the machines are designed for a huge variety of materials. So the machines is basically capable, to do, let's say, a lot. It's very exceptional, or almost never happens that we have to reach the maximum pressures or maximum, let's say, speeds of the machines. So what's important that is, if you found good conditions to compact and you increase the capacity, you increase the roll speed and you feed more material, there is always a point, let's say the machine goes up to, for example, the machine will go up to 21 RPM, but there's always a point where the rolls are running so fast that you will see that the compression, that the sheets will become softer, because there will be, it's so-called, also the dwell time, so you need time to compress the material. So that's basically the limit. So this could very well be for your material 15–16% RPM, and potentially not the maximum of the machine. It's something to keep in mind. But okay, you're talking already quite, let's say, potentially high capacity. So just keep that in mind if you would increase the speeds to continuously check the quality up to, to make sure that you don't go over the point where your material doesn't have enough time anymore to roll compact. So this is, this is a more, let's say, this is a better explanation on why this angle, nip angle, is important, because you're feeding from the top. This is the rolls. And the roll profile is important to basically grab the material in between and take it so it's compacted. if this angle is not there, so the point where the angle starts is basically where the material has the same speed as the rolls. So here there is some slip, which is normal, and then here it will have the same speed. If this angle is not there, I won't go too far in detail, but if this is not there, there's basically no compaction. So this is, yeah, let's say important, but that's not something you would typically, for example, measure. But you do control it by the roll surface. The milling, important step. So we basically have from, all of the potential, let's say, suppliers, we have the most flexibility on the mill. We use both a so-called knife rotor as well as a bar rotor for low energy milling. So depending on the material, depending on the hardness, you have actually more flexibility to optimize your granulation step. The product line of the CCS, so in our codes 223, 2520, that's the roll diameter and roll width. So in case of a 520, you have 5 centimeter wide rolls and 20 centimeter diameter. The diameter is also important across the line. So even on the next slide, you'll see this is the new machine we launched, and this is very unique on the market, to be honest. You have a couple of very simple things from on the market, which are small, but they are not scalable and not representative for the compaction process. The one we brought out now, and it's taken a while to design it, the one we brought out now is fully scalable across all our CCS lines. So it's really exciting. It can do just a few, up to 5-10 grams. You can basically compact. So that's a benchtop model. And maybe, I don't know how we're doing time-wise, let me check. But one of the questions I get a lot is to why, okay, when do you need recirculation? When do you need a single pass process? Single pass process meaning, okay, you have your initial material, you feed it to the compactor, you roll compact it into a ribbon, you granulate it, single pass, all what comes out will go to the basically tableting machine or to further processing. Recirculation meaning you have the roll compactor, you roll compact, you granulate, you have a single or double deck screener under the compactor, and you recirculate, you sieve the fines and you recirculate back into the compactor, and you take out, let's say, what is in specification. Okay, when do you need which process? It's obviously a good question. This gonna sound strange, but I will explain. This is a lot depending from country to country, and by that I mean I will give a couple of examples in, let's say, in Far East, where there is a lot of, let's say, copies around of roll compactors, which are, let's say, not as performant, not as efficient, and they produce more fines. People are used to those kind of lower quality compactors, which are not running as efficient, and so 90% of the customers there are asking, okay, we need to recirculate, because we need to recirculate the fines. If you look at main, let's say, mostly within Europe or in the pharma sites, if you look and let's say to a more performant compactor like ours, we are, let's say, amongst the top 3. And just for your information, in our company we've actually focused on roll compaction and milling only for, what is it now, 70 or 80 years. It's always been our key, let's say, knowledge. So if you have a really performant, let's say, compactor, then in a lot of cases you don't need to recirculate, because what you get out of the compactor will have some level of fines. I'll just jump back to where you go. Sorry. So what comes out of the mill here will have some level of fines, but that's fine, because you will have a particle size distribution. You will have a granulated material that's basically flowing well. you will have some fines in it, which are also required to make a good tablet. Because when you go into compress it later on, you will need let's say the little bit of fines in between the particles to fill the gaps in between the particle and make a nice smooth tablet. And as I said, recompressibility is very important. So bottom line, it all depends on the level of fines that you get out of the compactor. I would say typically up to 20, even 25% of fines. That's okay in most cases. So that's, if it's obviously higher again, and it depends on, well, it's not only the performance of the machine, it depends on the compression capabilities of your material too. Some materials do compact much better than others. But if the level of fines is acceptable, then a lot of times it's single pass. So the majority of the projects we do is actually a single pass project, to be honest. So here you see just a couple of examples. So this is a machine that's built through the wall. So the CCS designs are basically, very, very suitable. They're all in a front plate to minimize all of the technical, let's say, area from the process area. So it's nicely all in the front part of the machine and a vertical setup. So it's very, it's extremely nice to minimize all of the exposure and the parts you have to clean and all of the exposure in the process room. So that's, you can build it through the wall. It depends on preference, so you have technical area behind, and in this case there's a lifting column that feeds the compactor, and the result goes through the floor to the next floor. Excuse me. So high potent applications. Our CCS line is actually very contained by itself. So if you process the material, we've done tests only with our machine as it is, without an isolator box, that we can go up to level 4, which is high. The critical points are always, of course, the feeding and the discharging. I mean, the compactor is very well sealed. There's no, there's almost, like I said, we can go up to level OEB level 4. If, of course, you speak about OEB level 4 and 5, in some cases in level 5, for sure, you need to build an isolator box around the machine. It's also for secondary safety in the sense that, okay, if, for example, an upstream connection or if something would happen, there's always additional protection. So this can also be done. We've done, our design also leans very well to actually build it in this isolator, if that would be a requirement. And then the other thing, obviously, that's important is cleaning. So once you would open the machine, you break the containment. So in this case, wash in place is an option. One more thing maybe I want to mention is that we on purpose mention wash in place and not clean in place, because there is no, I mean, some of our competitors do mention clean in place, but we know also from customer feedback, there is no compactor on the market, let's say, where you can do what we call a true clean in place. And that means you would be able to you finish the batch or the process, you would be cleaning the equipment. So you would typically do that, okay, with nozzles, with water, with detergent, you have a drying cycle, and then without opening, you would restart it. That's through CIP. That's never possible with the compactor, because there would be always something, you always need to open it and examine the internal parts if they are clean. Simply because, I mean, the machine is actually probably 95, 98% cleaned when you do a wash in place. But the one area you always need to inspect, because we use pressure to compress the material, the one area you always need to inspect is around, let's say, the roll area. You cannot guarantee 100% that is entirely clean. So just to tell you, but there is wash in place options available, of course, also here. So yeah, I explained. So why Fitzpatrick? So I think we have the most complete range of the roll compaction line, fully scalable. That's very important. That's something we got back from feedback talking to our customers on so-called voice of customer program we did years ago, is that everything needs to be scalable from small up to the production size. Flexibility, you can see a couple of things here. Yeah, we focus these days on pharmaceutical only. People that know us from the past knows that Fitzpatrick has also been active in more chemical and other industries, but it's under IDEX, we focus entirely on pharmaceutical. That's why we're also bringing out, let's say, very new designs, which you have seen. Flexibility on the granulator. And like I said, it's our know-how. So from the process knowledge, I think within our company is also one of the very strong points. And I'm not sure on timing, so I think it's hopefully okay. But this is more or less, I think, in a very brief summary, more information about the roll compaction process. So I hope you found it interesting. And if there is questions, I mean, feel free to contact me anytime. I truly hope, fingers crossed, we can meet in person next year or soon. If you have specific projects, I've been traveling to Turkey a lot in the past. Okay, the last 2 years less, we all know the reasons, but yeah, contact us or contact, let's say, Thema is obviously representing us, who is a great team. So contact us and let us know if you have specific questions, or if you have an existing process and you have problems with your roll compaction, and we can support you. Yeah, we're very happy to engage and talk to you about that.